Hello.
Afternoon.
Yeah, afternoon. How are you?
Very well, sir.
Are we starting now?
I think we should just
I'm waiting for people.
I think we can just start.
Huh?
I think we should just start.
All right. So where did we stop last?
The last thing we did was we look at the rules of a clean data, the differences between index in Python and in R. Then you said that in the next class that we shall go to visualization with R.
Oh, visualization. Okay, because have we done machine learning?
No, we have not.
No, we've not.
We have not. Okay, let me just introduce you to machine learning with R. Maybe that last week we'll just try and do visualizations. Let me just introduce generally how you do machine learning with R. It's just similar to Python, only that you just see how it's done here. That's all. Then last week, I think next week we'll do the visualizations. Then hopefully, okay, but we'll just use this last 2 weeks now to finish up R, so that either we introduce Tableau next month, early next month, or end of this month. But let us try and wrap up R as soon as possible. Which data sets do we have? Let me see. We have, okay, let me see. Which data set have I sent you guys for? Okay, let me see. OLS. Okay, let me see. OLS. I've shown you how to get data from the already made inbuilt data sets now, isn't it?
Yes, sir.
Okay, let's use these two data sets. Let's use these two data sets and see. But I'll still show you how to break in other data sets. But let's just use this one first. Okay, let me start with the first one, OLS. So that's, what does OLS stand for? OLS, what does it stand for? What does OLS stand for? OLS. Yes.
Is it ordinary list?
Yes, that's ordinary least square now. That is your linear regression now.
You said ordinary.
Ordinary least square. Ordinary least square. Ordinary least square. This is foundation of all your machine learning models that you have building now. You know how a machine learning model that is built into supervised machine learning, isn't it? And unsupervised machine learning. Sometimes you can also break it into your deep learning. So you can break it into what they call deep learning or what they call reinforcement learning. This is also the same thing as your deep learning. But it all starts with what? Your linear regression, isn't it? Your linear regression. So that linear regression, the foundation is your OLS, ordinary least square. Ordinary least square. Ordinary least square. Okay? Because you know normally in your machine learning, now what we just do is that we use the data, isn't it? We use the data to learn. After we learn, we now use the word predict an outcome, right? Whether it's going to happen or it's not going to happen. So what we are trying to predict, right? If it is continuous in nature, continuous means it has different numbers. This is not 1, 2, 3, 4 quantitative data, right? They will talk about a linear word regression word problem. But where it's going to be a prediction of an outcome, either 1 or 0 or 1, 2, 3, isn't it? This is now what they call what? A classification word problem. So it can either be a binary classification or what? Multinomial classification. I'm sure we did discuss all this now when we're dealing with Python. I discussed a lot of the foundation of it.
Yes, we did.
Right?
Yeah, we did.
Yes, because I don't spend time to explain most of these concepts. All right, but just to show how it's built in R, that's my emphasis here. All right, so let's import our data. So what's the first thing we need to do now at this point? What do we do here?
The libraries.
Yeah, bring your library. So that the library should bring
Library, tidyverse.
library what?
Verse.
Tidyverse.
Deep layer.
Deep layer. Because all this is what you are going to be using to clear your data. Isn't it? If I want to bring my data sets, that was an Excel file, isn't it? So if I'm bringing an Excel file, how do I read an Excel file?
And read underscore Excel.
You read underscore what?
Excel.
But I have to first bring the library, right? Library, read Excel. Then I can now read the data set. I'll have to copy the path first, isn't it? So if I'm copying the path, now let's say I call it data, I'll assign it data, then I copy the path, isn't it? But I have to first say read Excel. Then copy the path. Then what's the next thing I'll do? I'll need to change it this way.
But, sir.
Yes.
I saw the other time that why don't we just use press import in that left side?
Okay, use import. Yeah, you can use import now. Because we are learning, so I need us to always know how it's done. Once I used to it, you can tell you what you like. But just to understand how it's done, that's all. In that OLS sheet, is there only one sheet that is there? Is there only one sheet that is there?
Yes, it's only one sheet.
Okay, say path does not exist.
There's only one sheet data.
There's only one sheet. Say path does not exist. OLS. Let me see the sheets. Yeah, only one sheet. Only one sheet. Right. Only one sheet. So let me copy my path. So you say path does not exist. So let's see it again. Path does not exist. All right, so let's view data. All right, good. Now you know how to slice through your data, isn't it? So if I have data and I have comma 1 to 2, what does this one? 1 to 2, what does this one mean? When I have my data, when I do this, what does this mean?
Only 2 columns, the first 2 columns.
The first 2 columns, isn't it? Good. If I want to check my columns, how do I say column names, right? I can say column names data. Can I see your columns there? So for example, so if I run this now, if I say view, will this work for us now? Can I see that? Give me everything. Now, if I put data -3, what does this mean? If I put everything -3, what does this one mean? -3, what does it mean? -3, what does it mean?
So it will count the column from the back, so it will only give us data for salary.
-3 means what? What does it do? -3 means what? Look at the data again. 1, 2, 3. -3 means what? -3, what does it mean? -3. Data -3. Look at what is going on. View. -3, what did it do?
It only brought out the first 3.
It brought out what?
First 3 columns.
-3 means remove that other one. So how many columns did we have?
That's 4 columns.
4, is it not? We have how many columns there? Where's my view data? See what we have. 1, 2, 3, 4. Is it not? Now -3 means what? So this is 1, 2, 3. So let's see what when I say -3, what did it do?
Oh, it removed only the
It
third.
removed. Is it not? So if I want to remove that last column, for example, I want to remove that last column. How many columns do we have?
4.
4. So if I do -4, it means what? Remove that last column there. Can you see that? Now this is what we're trying to do the last time now. When we're doing data manipulation, how to remove columns, select between columns, is it not? So if I want to select, for example, I want to select between the I want to select age and experience. How will I select age and experience now? Age and experience. I want to select age and experience. What will I do? Age and experience.
1 and 4.
Age and
1 minus 4.
age and experience.
Or 2 column 3.
Exactly. So it will be what? Data 2 column what? 3. So let's view that and see. Can you see that? Because you know most time when you are looking at when you want to start your analysis, not all the columns you require. Isn't it? But you may require all the data sets, but not all the columns you require. Isn't it? Then another thing again we want to check is that is there missing data? How do we check for missing data? How do we check for missing data? Is.NA, right? Data, right? That should be false or false. But if I want to check if if there's anyone at all, it's not any missing data. False. False means what? False means what?
Note that there's no missing data.
No missing data, exactly. No missing data. Then I can view the structure of my data, right? Or either I can use glimpse data, isn't it? Then I can just see the data there, or alternatively, I can use structure of data. Any of them should give me the same things. All right? Any of them should give me the same thing. Now remember, before you do anything machine learning, all your data must be converted to numeric. You cannot use text to run it. I hope you remember that.
Yes.
Yeah, you cannot use raw. That's why you need to always know how to transform your data. Okay. Then if you want to do a summary, you can do your summary statistics data. Let's see, that is summary statistics of it. If you want to do a correlation, how do you do correlation? Correlate what? Data. Can you see the correlation? Yeah. So that's the correlation, all right? So if we are to do let's say a simple regression, isn't it? For us to do a simple regression. Now. So if I look at this data now, let's say view data. If I look at this data now, which one do you think is dependent? Which is independent?
Salary is dependent.
Salary is what?
Dependent.
Dependent, okay. So that means we are looking at the factors that were explicit basis salary, isn't it? Okay, so if that is the case, so let's say, for example, let's pick only one. Let's pick only one factor. Okay, let's say we are working with salary and age, right? So salary becomes what? If I'm working with salary and age, that means salary will become what?
Like the Y.
That's y. So it says y as a function of x, isn't it? So here we have salary is equals to what? Beta 0 plus what? Beta 1 what? Age, is it not? Plus the error term. What kind of model is this?
Linear model.
Linear regression.
Yeah. Linear, but which type?
Simple linear.
Simple linear regression, and that is a simple linear regression. Okay, why is it simple?
It has only one. It has only one dependent variable.
Yes, it has only one dependent variable. It's not one dependent and one independent variable.
Yes.
It's not one dependent and one independent variable. All right. So let's go. So let me take this off.
Sorry, sir.
Yeah. Okay. All right, let's go. Now, if we look at the data now, right? So now I want to run the regression, isn't it? So running your regression now, we can call it maybe either I want to call it model, right? Either I call it model or okay, let's call it model, isn't it? So the function is LM. LM, can you see that? LM, linear model. LM is what? Linear what? Model. Okay, so what's the formula now? Formula is what? The dependent variable is what? Salary, right? So you can use this. You know how we have written the model is that salary is equals to what? Maybe A plus B age, something like this, isn't it? So this salary. So instead of using this equal to, they use this symbol now, this tied symbol. So let's do that. You know where the symbol is it not? Underneath your escape button, isn't it? Then you put your what? Age there. they can put age there. And remember, when you are running it, if you put ln open brackets, you see the syntax. So if case you don't remember, it's not like I remember. Once I just put it, I'll just say, okay, formula, data. Can you see that? Then you can put whatever you need. Alternatively, I think you can put question mark ln. Let me see, question mark ln. How? So can you see that fitting? So you can now see documentation. Can you see the documentation now? This is documentation. They will give you an example somewhere down. So you can copy that example and use. Can you see that? So that's where you read about it. Can you see that? So that's how they have run it. Okay. So let's go. So what we are doing next. So let's look at it. What do we have next? So after the formula, what do we need? We need the data, is it? We need the data. What's the name of the data? What's the name of the data?
Willis.
Willis.
Data.
Data. Because that's how we put it in the variable. Isn't it? That's how we call the variable here. We call the data here. That's why you see sometimes because he already has an input function called data. So call it data, they look at it at the same thing. So that's why again, watch how you call your data. So it's good. Maybe we don't always call it data. You can call it any other name, but you get what's going on there, right? So every other thing may be more like, so once I've done that, if I type model and I run it, remember the objective is to determine my intercept and my slope. So what is my intercept now? What's my intercept? What's my intercept?
Minus 20.96.
Minus 20. And what's my slope? And my slope? And what is my slope?
Point 66.
0.66.
Yes.
0.66. So which means that if I have my salary, A is now what? Minus 20 point what? 96, is it not? Plus what? 0.66 what? Each. Can you see that? So what I've done here is that I have what? I have done what? I have brought my, what do you call it now? I have brought out the equations, the regression what? Equation. I brought out the regression equation. Okay, I brought out the regression equation. Okay, I brought out the regression equation. Let's say, for example, now, what I can do, I can copy it. So this is what salary and age, now, is it not? Let's see our age. So let's look at age. Can I see age? 41, 42, 43. So assuming the person is 60 years old. Assuming the person is 60 years old, what do you think the person's salary will be? If the person was 60 years old, so let's say age, let me say age is equals to 60, right? What will be the person's salary? Okay, so I will not have to use this equation out. So I can just copy this number out. I can now have this plus what? This. So you can say I want to use the full thing, is it not? Sorry. Times age. Will you give me anything there? Say age not found. Age not found. So let's say age. If I assign it to age 60. So let me use that. Did he give anything there? What did he give us? What did he give there? So I can say salary is equals to, so I cannot say view, I cannot call salary now. I can say print salary, print salary. Can you see that now? So this salary is what? It's in print. Let's say print the salary is, does it work this way? Print the salary is, the salary is what now? Will this work now? So salary is, let me put salary there now. What did he say? See all the expected. Okay. Salary is. Will this one work? Free salary. No. I want to call this salary here. Okay, what I'll do, I'll put it there and I'll say salary is salary. Now with R, how does R pick it now? If it was Python, now we have done it in Python now. How would we have done it in Python?
We have put a comma after the string.
Put what, a comma here, right?
Yes.
All right, so let's see. Salary is so if you want to read this for Python, I'm not sure how I will read this almost. But it was Python. Now, if you put it there, I will put the semicolon. It will read it as a variable there. Okay, don't worry. I'll look for how to do that. But so let's say salary. So salary is what? So let's throw salary there. So you see 18.877. So if I come 18.877. Okay, let's say for example, where this age was 46.2, is it not? It predicted 9.8, is it not? So 46.2. So let's check 46.2. So where age is what? 46.2. What did he print? 9 point what? 9 point what? 64 or 9.64. So 9.64. This one predicted 9.8. Is it too far from it?
No.
It's not too far, Navi. So you can just test it randomly, right? You can just test it randomly and check how it is. For example, if I have maybe like a series of numbers I want to test now, so I can say, let me see. If I want to put it in a data frame now, you want to put it in a data frame. You know what, if I also put it in the data frame, right? So let's say I have different age, assume I have different age values. So assume I have different age values, different set of age values. So I want to predict the salary based on the different age. I want to predict the salary based on the different age. Okay. So let's say we now have let's say for example, we now have so let's say new data set, right? New data sets. So let's say data, you know, if I want to put it in the data frame, so I'll call it data frame. Let me say age, right? Age is equals to, so maybe I have what, 30, let's say I have 40, let's say I have 40, 43, let's say I have 45, let's say I have 50, let's say I have 60. So this is my new data now, isn't it? So I have a new data. So I want to do a prediction for 30, 40, 50 years old. So if I have view, let's see. So this one will work. Let me see new data. This is new data. Okay, that's the new age, right? Good. So if I want to predict, so if I say predict, so predict what now? What's the name of my model? Okay, predict model. Predict model. What's my object now? New data is equals to what? New data. New data. Can you see what it has done? Yeah, but this one does not make any sense now. Okay, this is 5 point, this is 3, this is 8, this is 12, this is 16. But this first one is pretty negative. Let me see. Okay, if I say 41, let me see. Okay. You know why it's negative? You know why it's pretty negative? You know why I
Yes, sir.
predicted it as negative?
No, sir.
Now, if you look at the original data set, if you look at the intercept, can you see the intercept is what? -20, is it not? Now, take note of the age. You see that there's nobody that is below 30 in this age. Can you see that? Can you see the age? There's nobody that is below. There's nobody
Yes,
below
sir.
40. Can you see that? So when you are putting outside the normal range, so that's why it's not coming up to this point. That's why it's predicted as negative. Do you see that? So that was the
Yes,
reason why.
yes, sir.
So that's why you see when you are building your model, you must also balance accuracy with interpretability. It must be interpretable. Okay. So we can easily predict it like this. So this was for a simple regression model, isn't it? This for a simple regression model. So if we have multiple regression model, now how do we go about it? Multiple regression model.
Sir,
Yeah.
so that means this the object model and the new data, the one without
Yes.
the underscore. So that means they are like Python, Python, they are like R functions, right?
Yes, now they are look at it, they are part of the this thing now, guys, that they are part of the arguments, formula, data, model, they are part of the arguments. That's why you see when you are labeling it, that way you have to be very careful with the labels so that most of them you have model, you have data. So we can be calling them something else so that we don't enter problem with it. So like all those model data, they are already Python reserved and R reserved arguments. So for example, we have other data sets, right? So let's say, so let's look at, so we have salary age. So if I want to run a multiple regression now, multiple regression will now be what? It will now be salary. Is it not equals to what? Beta 0 plus beta 1 age plus beta 2 what? Experience plus beta 3 performance. Can we see that? So now this is a multiple regression model, isn't it? Because now it has more than one independent variables or more than one predictors. So the same way we are going to try to build it down. So let's build it down. So let's say model 1 equals to now linear model. What's the formula now? Formula is equals to what now? Formula is equals to what?
Salary.
Salary. Please make sure that the way you type salary is exactly the way it is there. You don't have age.
Performance.
So it will be age plus what? Now, what are the other variables?
Experience.
Experience. Plus what?
Qualification.
Let me see. Age,
Okay,
experience,
performance.
So performance. It must be the way it is spelled there. Performance. All right, good. So now we are done with that. What's the next thing? So once we are done with the model now, what's
Reference
next?
the data.
The data, is it also? We need to call the data. We need to call the data. All right, and what's the data? So data is equals to what? What do you call data, right?
Data.
All right, data, yes. So let's see, spell it down. Model. Please to be checking your spelling. So if I call model 1, so let's check. So that is it. Can you see that? Now remember again, if I want to bring out the model in full, like you have in Excel, where you see the arrows. So like for example, we have all the arrow square. The arrow square, the F, the T test. Where are the results for that one? So where do you find the results of the arrow square, the T test, the F test? Where are they now? Now, if you want to do it, what you just do, just a summary of model 1. Can you see that? For simple regression, you actually don't need all those parameters like all those arrow square and the rest. But you see how you have it just like in Excel, is it? Now, which of the variables are significant here? Which of the variables are significant here?
Experience and performance.
Experience and performance. How did you know that? How did you know?
The p-value.
Yes, the p-values are less than what?
5%.
Can you see all the ones that they put stars here? It means significant. Can you see that? Significant at 1%, 0, 0, 0. Can you see that? So anyway, you see star, a star being significant. This one means what? Not significant. Okay. So that's how you are going to see, because most time, because it's coded, it's just as if it has brought all the results in one place. You know, and because there are so many numbers, you cannot even differentiate what is what. So you can see arrow square. What is the arrow square here? Arrow square is what?
0.91.
Is that high or low?
It's high.
So how do you interpret it now? This arrow square.
What you told us then was that it depends on the field, or within the significant level of 0.5 to 0.1. Okay.
Yeah, I'm saying this arrow square. How do we interpret this arrow square?
That means 91% of value was used to.
Was explained.
Yes. Yes. Good. Arrow square with a value of 0.9 implies what?
That salary, that 0.9, that 91% of observation salary that was by experience, performance, and age.
Yes, that 91% of salary is explained by what? Age, experience, and what? Performance. Can you see that?
Yes.
Now, this is F. To confirm the statistical significance of F, is it significant or not significant? Is it significant or not significant?
It's significant.
It's significant, is it not? So it tells you that F tells you the overall significance of your model. Is it not? And it tells you that the overall model is what statistically what significant. Is that all right?
Yes, sir.
Good. So we are clear with this now, isn't it?
Yes, sir.
All right, good. Now let's say, for example, let me see. Okay, maybe let me use another library. Okay, let me use another data set. Let's use another data set. Maybe I'll explain some of that things there. Okay, let's use a new sheet. So let's use a new sheet. So like in Excel looks more user-friendly now, isn't it? But the results look scary. Now, if you don't know what you're looking for now, you just be as if so I just code. But you see that this result does not look so pleasing, is it not? So now it's just better just copy it and then carry it to Excel and adjust it the way you like. Okay, so sometimes you may want to import certain things. Remember, if I run data, if I put question mark data, it will show me everything about data. Or if I just run data, okay, this is called data because okay, let me put the bracket and see. Let's run and check. So this one will give you the list of all the data that you need, right? So you give you a list of data here. Okay, so that's one way to get data. And that one again is that depending on the package you get, there's one library called, I don't know if you have looked at that library. So let's say library Datarium. So that's another library again. Because this one also has a lot of data sets. So if I say data, this one has its own data. Can you see that data sets in package Datarium? It's not list only the package data in Datarium. Can you see, for example, you have marketing data sets? Can you see marketing data sets? So if I want to read this marketing now, how do I read marketing now? If I want to read marketing now, how do I read marketing? I just say data marketing. Data open bracket marketing. Let's run and check. It's as if nothing has come out, isn't it? So what if I view everything now? Let's see if I view everything now. Now, but everything is not coming out here. Or alternatively, you know what I can also do? I can just go straight and type view marketing. I'm sure this will come out. So can you see that YouTube, Facebook, sales? So if I look at this data now, what kind of problem is this? What type of machine learning problem is this?
The regression.
It's a regression. How did you know it's a regression?
Because it has a continuous independent
Because
sales.
that is all you need to learn from there. What will be the dependent variable?
The sales.
Sales. So sales as a function of what?
YouTube, Facebook, and newspaper.
Facebook and newspaper. That's all now. So let's build our. So we understand how to identify them, isn't it? Where is it? All right. So we have got that now. So if I want to read my model now, how will I read the model? So I can call it. What should I call it now? So that you know, what variable should I call it? Should I still call it model? Are you comfortable with model? Let's see if we use model now. So what will be the function? Linear model. Then we have what the formula. Is it not formula? Yes, formula is equals to what? What's the formula now?
Sales is.
So I can write my column names, marketing. So I will see on my this now. So dependent variable is what? Sales, is it not? Then we have what?
YouTube plus Facebook plus newspaper.
Exactly, YouTube. Hey, there's one thing I wanted to show you. There's another way again, I think you can do it. You can put, I think you can put a comma and full stop. Comma means everything there, full stop. Let me check if it work for this case. Because there's another way you can, instead of me calling it, you just bring all the remaining variables. If it's all the other variables you want, I think you can do it this way. Okay, let me test. Where's that first one we ran? Okay, let me copy this down. Now you see where we have used. So I'll put a full stop there. Can you see that? I'll put a full stop here. Let me run and check. Did it work? It works. Can you see that? So instead of me calling everything one by one, I'll just put full stop there. So I'll just put what? A full stop there, comma. I hope you understand it now.
Yes.
You understand that full stop? That full stop means everything. So it's another way of still writing it this way. It's another way of still writing it as YouTube plus Facebook plus newspaper. Now, you know, because this is small, so it's easier for you to type everything. Assuming you had like 10 variables. Now, you see that if you have like 10 variables, now it will be quite lengthy to type, right, isn't it? So you can just use that full stop. Marketing. I hope that is clear. So take note of it just in case you see it, you understand what it's doing there. So that full stop is like say, give me everything. Okay, so if I run this one again, let me call it model 1. So let me now take this guy out. Right, I will now put a full stop there. So that's model. So if I call model 1, can I see that? Let me call model. Let me run model. Model. Are they the same thing? Was it the same result?
Yeah.
Yes, sir.
The same result now. So which one is better for you?
Command dot.
Because I would say give me everything, but that's a faster way of doing it. Okay. Now, just the same way we predicted for our, we did our prediction now, isn't it? We now predicted, but now because we have several variables now, so that means we have to predict with the variables, with each of the variables. Okay, so for example, I can have let's see. Now remember, what's my equation now? What's my equation? So I have what? Sales is equals to what? What's my intercept? 3.5. Is it not? Plus what? 0.04 YouTube. Yes. Plus what? 0.18 what? Facebook. Minus 0.001 newspaper. You see that? So how do we interpret this? How do we interpret this? How do we interpret this? 0.04. What? How do you interpret it now? How do we interpret it? Yes. Yes, how do we interpret it?
So just to understand the question, you said how do we interpret this just
This-
0.04?
Yes, this one, how do you interpret this variable here? Or this one here, how do you interpret it? Remember, normally when you interpret, you normally ignore the intercept. It's only when you are doing prediction that you use the intercept, but for interpretation, you don't interpret it. So how do you interpret that coefficient there? Yes, how do you interpret this?
Of the total 3.5 million, 3.5 sales, 0.04 of it was from YouTube.
Is that how it's interpreted?
I think it has to do with correlation, the level of correlation
Yeah.
of
Okay.
YouTube.
So it will be what now? Yes, it's like correlation, is it not? So what does it tell you now? A unit increase.
It only it showed
A unit increase in the coefficient will result in 4.5% unit
a
in
unit
YouTube.
increase in YouTube, is it not?
In YouTube, yeah.
We what?
Will result to 4
increase sales
by 4.5%.
by 0.045, but it's actually not a percent, it's just in units. So it can be kobo,
Okay.
it can be cents, it can be whatever.
Okay.
So if this 1 unit means, if it's 1 naira, it means it will increase by what? 4.5 kobo. If it's $1, it means it increased by 4.5 cents, approximately 5 cents, right? Why Facebook? If you increase your advert with Facebook by $1, your sales will increase by how much? 18 cents. Can you see that? Okay, let us try and see. Let us put all of them as 10, 10, 10. Let us see what will happen. But this newspaper, what does this one tell you?
It will be a reduction of 0.00.
Yes, if you increase your advert
doesn't have
by
impact on
$1,
It
does
has
it mean that it
impact,
doesn't have impact?
but negative impact.
negative.
No, that's the relationship is negative. But check, if I want to check the correlation, the significance, now I'll do a summary of model. Okay, summary of model. So let's now check. Actually, yes, it doesn't have impact. Can you see that? But it's not because of this value that it doesn't have impact though. More of this. Okay. So let us now see if I now put maybe 10, 10, 10. Let us now see if I want to now do a prediction now, right? So let's say, for example, so let's predict. So predict model. What's our data set? Okay, let me just create the data frame first. So let's say data frame. So let's create the data frame. So let's say you have YouTube. Let's say YouTube equals to 10. Let's say Facebook equals to 10. And let's say newspaper is equals to 10. All right, so let's see. Which one should now? So can you see what that has predicted only one for us? It has predicted only one for us. But if I increase this to 100, let me see, 100, 100, 100. Maybe we're gonna check. Can you see what has done? So that's the predicted value. So how is it done? It means it's 0.04 times 10, is it not, or 100? 0.18 times 10 minus 0.01 times 10 plus this amount will give us this amount. I hope you remember how we did it in your simple linear regression. Do you remember how it's done the simple linear regression? Is this clear?
Yes.
If you remember our simple linear regression, how we had added it. Where was it here? Here. Can you see what we did? It was this plus this times that value. But in this our own case now, we now have more than one. Can you see that? We now have more than one independent variable predictors. So that's why we have to now put it in this format. Can you see that? We now have to put it in this format. So it will now predict that value for me. So that means it's 26. I hope that is clear.
Yes, it is, sir.
All right, good. Sometimes again, if you want to, even as we have predicted it like this, right? Even if we have predicted it like this, what we can also do, let me see. I think they also have interval. Let me see if I can get the interval. Let me see. I think there's interval. So interval, I'll put confidence. Confidence. How that's the right spelling? Model. Okay. Did it bring out interval? Do we still run it that way? Let me see. Is there that way I can get the interval out? What if we let's try to see if there's any other way that we can. Okay, no, let me just leave that interval first. But that interval is just to show the range, right? Just to show the range. Just to show the range. Well, let me see. If I predict the model here, let me see the interval there. Why is that coming out? So predict model and I'll put YouTube, put newspaper, then interval. Oh no, let me see. Let me see. It's supposed to bring this value, right? Then also bring out the values along with the confidence. So I don't know why it's not bringing it out. Okay, let me see. If I use this smaller, will this make any difference? What if I say data, let me say predict, let's say P. It's the same value. It's supposed to bring out everything for me. It's supposed to bring all the interval out for me. Or maybe you can try it your own. I don't know why it's not coming out, but if you want to bring out the confidence level, they should bring it out that way. Then you know that again, see this your values there. You can also write it to Excel. You know how you write in Python to CSV, you know? So here you can also write .csv. Okay, write .csv. So you now write it. I can't remember. Let me see. Write .csv. Let me see. So if you write it down, okay, then the file. Okay. So I can say write predicted, comma, predicted.csv. Let me say, okay, let me use P. Let me use, which one will I use now? predicted, right? So let me call everything here predicted. Let me call everything here predicted. Predicted. All right. So this is the predicted. So I want to write it in a file called predicted.csv. So which means it's expected to create a CSV file for me called what? Predicted.csv. So, but where will I find that file now? I hope it will be on my desktop. You know, if it's not your desktop now, that means you have to go and look for it in the folder where it's normally saves predicted.csv. I don't know where it is, so let me type predicted.csv. You know what we are trying to do, right? Good. You know what we are trying to do? You know, based on the file that we predicted. Can you see it here? Can you see the value there?
Yes, sir.
So that was the answer that we are getting. So that's the value. So I was thinking that it should give us the range. But if you want to write the values out, that's how you do it, to write it to Excel or CSV file. So it's after you have finished prediction, you can now send it to a CSV file. So if you want that tonight, implement that file, maybe you want to import it to your Excel file so that you can easily take that as an output of as an input into your analytics. You want to now say this is the prediction so far. So that's how we can link our R with our Excel. So you now export it there, then you can now go and do the prediction, visualize the prediction or show whatever you want to do with it. But later you can try it on your own and check whether that's your confidence value will come out. But normally just to show you the confidence value there. All right, I hope we're okay with regression now, right? Are we okay with this regression?
Yes, sir.
We're okay with regression, right? Good.
Yes.
Okay, let's see. Which other data set do we have there? Okay, I think I sent another one, another data set, right?
Two, OLS and
social network ads, yeah. Social network ads. Let me see. Let me open that file first. Social network ads. Social network ads. Good. So can you see the file here? Can you see the data now? Now, of all this one, is it everything we require? Is it all this data we need? Is it all the data we need?
No, not all.
Yeah, so which one do we need and which one don't we need?
We need age, we need estimated salary. We need user ID.
Yeah. You need what? User ID. What will user ID do for you?
It's like a primary key.
Now, what I do with the primary key now? Your prediction.
Oh, okay.
you're saying the primary key is not needed.
Is there?
The primary key is not needed in prediction.
It's not needed, is it not? Gender, do we need gender?
Yes.
No, we don't. We don't need gender. Unless
Now, if you say you need gender, but I cannot work with gender like this, is it not? Then in that case, I will need to transform it. Right? But I will now have to ask myself, which gender? Because remember, whenever you have your variables like this, yeah. So if I'm interested in female, I will assign 1. Otherwise, 0. Can you see that? Female, otherwise 0. That means gender. I'm interested in female. If it's male, I'm interested in. Anywhere I see male, I'll put 1. Otherwise, 0. Okay. But if I'm not interested in gender, if I cannot explain how gender will want to purchase, I just want to whether they will purchase or not purchase, isn't it? Then all my data I'm going to use must be quantitative. That's the only way it can work. I hope that's clear. Okay. So which will be my dependent variable now? What will be my target variable here?
Purchased.
Purchase, is it not? Purchased, is it not? So it's either they purchase or they don't purchase. If they purchase, what do we assign?
1.
1.
1.
Otherwise, 0. So 1 means purchase, 0 means not purchase. Is it not?
Yes, sir.
So what are our features now? So the model will now be what? Purchase is a function of what? Age and estimated what? Salary. Is that not it?
Yes, sir.
So because my dependent variable has only 2 possible outcomes, is it not? Whether you purchase or not purchase, 1 or 0, is now called what? Binary. Is it not? So what we are using here is called what? A binary logistic regression. We are using what they call what? Binary logistic regression.
Okay.
So whenever you hear logistic regression, they are talking about what? Binary logistic regression. Binary logistic regression. Clear?
Yes, sir.
Clear? All right, good. So most of the machine learning models we are going to be doing it. So maybe I'll just open a new one so that we can read it clearly. So to clear this guy, Maybe I can. All right, good. Let me copy my file path now. Where's my file path? Let me copy that guy out. So I'll need to bring in my library. So library. So maybe I can have my tidyverse, library. I can bring in my words. Now this file, is it an Excel file or a CSV file? CSV. So if it's CSV, what do I call now? Library. Which library am I calling now? For CSV file.
Read CSV.
For CSV file, read what? Read R. Is it not? But when I want to now call it down, I have to say read.csv. Can you see that? I will now read it.
Is it read dot or read underscore?
It is read dot. Let me see. Okay, is it read dot or read underscore? Let me see. Wait, let me try it again. Read dot is read dot csv now. Read dot csv. Did I call everything? So let's check it out. Reads. Yep, that's it there. So I'm gonna say view. Can you see that now? So if I want to only select age to or purchases, how will I select age to purchases now? How will I select only age to purchases? since I don't need everything.
Brackets, comma,
3 to 5.
It will be what?
3 to
DF what? 3 to what?
5.
View. Like this, is it not?
Yes, sir.
Now, if I now do this now, maybe I now do this. If I now say data, what does this one mean now? What does this
Assigning
mean
it.
now? I'm assigning it, is it not?
Assign.
Now I only have this. Can you see what we have done? I will
Yes, sir.
just selected the columns that we require to work. Now you see, when you are dealing with machine learning models, right? You know the first thing you will do is to what? Get your data, isn't it? Clean your data. We did not check whether this data is clean or whether there's are there missing data. Are there missing data? How do we check if they are missing data?
Is.any.
Eh?
Is.any.
Is.any. So say is.any data. I don't know, but if I check any missing data, so false means what?
There's no missing data.
No missing data. All right. Now, if I want to check for that, my data, so you know how you can explore it. How many rows do I have here? I have 400 rows. How many columns do I have here? How many columns do I have here? 3 columns, isn't it? What again? If I want to check the structure of data, now we see that. So you can easily read either, or I use glimpse data. Can you see that? All right, good. So I've gone through it. Now, once you have finished exploring your data, isn't it? Once you have finished exploring your data, now another thing again we need to do is that in machine learning, right? You know what we normally do is that when we look at our data sets, when we look at our data sets, once we finish collecting the data, we have identified, okay, there's no missing data, there's missing data, now once your data is cleaned, the next step is to do what? You need to choose your variables. Now we have chosen the target. We know the target variables, we know the features, now isn't it? We know the target, we know the features. Now the next thing to do is to now do what? Break your data into 2 parts. We'll break our data sets into 2. What are they? Trade and what? Test. Is it? So what we are doing here, we are splitting the data. We are going to what? Split the data into what? Trade and what? Test. Is it not? We'll break the data into 2: trade set and test sets. Okay, so we need to split it. Now to split your data, you will now need a library. We will now need to bring in a library. Which library can we use now? Now there's one called let me see now. So library, so there's this library called car tools, classification tools. Look at it, classification tools. But in case the enemies are at work and you run your own, it doesn't work. So what do you do? If you run your own and it doesn't work, what do you now do?
Go and install it first.
You will install it. It's not, how do you install it? How do you install it?
Install the package.
Install.package, that's it now. Install.package. So you just say install.packages, is it not? Car tools. So you run it. Okay, car tools, and you run it. All right, good. So once I've brought in my library, So once I brought it in, once I brought it in, now the next thing I can do is to, if I want to do splits, but again, if you want us to have the same result, right? If you want us to have similar results, so that anytime you run it, we'll be having the same thing, you can do what they call set seeds. You know what set seed is doing? If I say set seed 100, you know what it means? It means based on this version I have, or I can say set, yes, 100, 200, 300, 1, 2, 3, any value that you want there, such that when you look at the data, it will mix it up to this pattern. It doesn't mean 123 data sets. It just means the pattern I want. 1, 2, 3. That's all. Okay. So when you pick 1, 2, 3, let me see. If I run, can I view the data now? Can I view data? But it will not allow me run it. It will not allow me see it yet. But it has split it. So it will just set it for me. But you can't see the data yet. Unless when I start by splitting. All right. So if I want to do, once I've set my seed, that means just to ensure that we have the same data set. Because remember, when you are splitting, it's going to split it randomly. So even when you pick it randomly, to ensure that we have the same data set, it will split it based on that. Okay. But if you don't want it, that's fine. You can leave it out. That doesn't really matter. So if I want to split the data, how do I split it down? Okay. Now what I'm going to do is that I need a sample. It's not. I need a what sample. So you see sample split. Can you see sample split? Sample split. Now remember that when you are picking your data, you are using either the 80-20 rule, either you're using what 80-20 rule, or you're using the 70-30. Okay, so it depends on the size of data. So sometimes they use 80-20, sometimes 70-30 as the spirit leads. Okay, but most time you see them use maybe 80% or 80-20. All right. Now, what is my target variable here? What's my target variable here? Let's look at it. So look at this. Y stands for what? What does Y stand for? What does Y?
Dependent variable.
My dependent variable, is it not? And my dependent variable is what? What's my dependent variable?
Purchase.
Purchase, is it not? So if I want to bring out purchase, how do I bring out purchase now? I want to bring out purchase alone. How would I bring it out? I want to bring out. Yes.
$.
Yes. Purchase. Can you see how it has come out now? Then you have what they call, what do we see just now? So split ratio, is it not? Let me do it again. Let's see sample. So what I can do, let me put it sample dot split. So I can read it here. Because sometimes I will not remember all these syntax. Can you see that? So once I just put a question mark, I'll put it here. So I can read what can I know what to put here. Okay. So can I put so you now have split ratio. Split ratio stands for what now? So split ratio. Split ratio stands for what now? 2/3. 2/3 is what? 2/3. 2/3 will be what now? 3/4.
66.
66. The
0.66.
let me just use as 0. Use as 0.8. Use your 0.8. That's 80%. Use your as 0%. 80%. 80%. All right. So 80% means I'm going to split it 80-20. 80-20. Hey, by the way, 80% of 400 will be what? 80% of 400. We have how many data sets here? N rows. N rows. Where did everybody disappear to now? Show all it. Yes, n rows data. So 400. 80% of 400 will give us what?
320.
320. So it means that if I break it down, that means my train set should be 320, my test set should be what? My test set should now be what? 80, Abi. Okay, 80. All right, good. So now, once we have got that, so we have said 80%, is it not? So we need to specify my train sets. So train sets. So train set will be what now? I can now use a subset of my what? Data. Is it data I called it? Yes, data.
Yes.
Okay, call it data. Okay. So split is equals to true. Can you see my split now? My split is equals to what? True. So let me run this and check. So if I view this now, let me see. View train sets. So how many does it give me? How many does it give me?
320.
320.
320.
So this is correct now, isn't it? So it means for my test sets,
Yes, sir.
test sets will now be what? Because anything you do for your trade, you must do for your test. Anything you do for your trade, you must do for your test. So it will now be subsets of data or split equals to false. Why are we putting false in this case here? View test sets. So this is 80 now, isn't it?
Yes, sir.
Yes. So you remember we have already split it already, is it not? So it is just the balance that we are taking here. Do you get that? So it's not so that I don't go and already split data. Do you get that? So it's the balance from here that is put in here. If I go and already split data, it's like we will now take 80% of that 80% of that 80. Okay, it will not give us another thing. Now, once you have done your data trade and you have split it into what? Trade data and test data, isn't it? Then
Yes.
for I don't know when we are doing with Python. I hope you remember when we did this in Python, right? We did all this in Python, isn't it?
Yes.
Which one is easier, in Python or R now?
So no again.
I think Pythons are.
Oh, yeah, I used to Python. Okay, Python is easier.
Yes.
Okay.
I think it's not the one we are used to, like the one we've done. Because we practiced that one before. This one is
Not
looking like,
necessarily easier. It's what you are used to.
exactly.
Okay. But you see, it's really not about the programming language. It's about what you are trying to achieve. I collect my data, I clean my data, isn't it? I transform my data, I will now split my data. And test. So you just to ask yourself, okay, how do I do it in Python? How do I do it in R? But it's the steps that really matter, what you are trying to achieve. Because at the end of the day, R and Python is just a means to an end. Okay. Then we also can scale your data. You can also scale your data. Now, why do you scale your data? If I come here, can you see, for example, now, do you see your feature is just a single value? Can you see this is double digit? This is like how many digits now? This is like 5 and 6 digits. This is 5 digits, you know. So you see, they are not in the same unit. They are not in the same unit, is it not? So what you will now need to do, you need to scale it down. You need to scale it down. You scale it down so they can be on the same level. Okay, so that's why you do what features, they call it feature scaling. Feature scale. Have we heard of feature scaling to scale your data? Feature scale just means bring them down to the same level. That's called feature scaling. But remember, which data set am I using now? Is it both variables I'm using for my feature scaling?
No, you want to scale one to the size of the other one.
So that is age and what? Estimated salary, is it not? Age and estimated what salary. So that's what I want to scale, isn't it? So which means for my train sets, now, isn't it? So if I want to scale it now, I want everything 1 to 2. I hope you understand what this one means now.
Yes.
You understand what this means?
Yes.
All right. So I'll now scale it. So train sets. I will now scale. All right. So let me check. So let me run it now. Check view. Train set. Let me see view train sets. Can you see what has happened now? They have now been brought scaled down to the same level. So they are called scaling. Because remember, it is not the value it's looking for, it's looking for the pattern. I hope you remember what machine learning is about, pattern recognition, not exactly matching the number for numbers, matching the patterns. Okay, so what I have done for the train set, I will do for the test set. So I'll copy these two. So I'll call this one what? Test sets. Call this one what? Test sets. And I will run this one again. So if I want to view test set now and run it, can you see that that's been scaled down to the same level? So this is called feature scaling. So next thing we need to do is to scale our what? Data. Now, once you have scaled your data, then I think you are now ready to fit your model. So ready to what? Train your model. So when they say train your model, what does it mean? Or fit your data. Or what does it mean to train the data or fit your model? What does it mean? When you are training the model or fitting the model. It's just simply means run the regression. It simply means run your regression. So at that stage, so when you say I'm training the model, what are they doing? Yes, please running the regression. Okay, but remember now, based on my feature, my target variable, right? Can I use regression? Can I use linear regression?
No.
You can't use linear regression. Is that so? Which model are you going? Which model are you going to use now? Logistics, is it not? So I'm going to now use what? Logistics. So logistics is under what? Classification. So maybe I can call this classifier, right? Let me say classifier. If I want to call it, so you know, we call it model, I can just call it classifier, right? Classifier model. So here we use LM. So LM is linear model. But for logistic regression, we're going to use what they call GLM. Generalized what? Linear model. Can you see that? GLM. So we are using GLM. So the same with formula. What's the formula? What's the formula?
Purchases.
Purchased. Is it purchases or purchased?
Purchased.
So purchased. Okay, it's purchased. Okay. Yes. We understand this. We understand this.
Yes, sir.
Everything.
That full stop means what?
Everything.
Every other thing. Every other thing. Then family means what? Which family? Binomial. It means what? Binomial. Is it not? What's my data set? Which data set am I using? Which data set am I using?
I think we called it. Data. No. Sorry, train set.
You know, we have data set. We are broken into the train set and test set. So for the first regression you are running is what? Is it the train or test you are doing first?
Train.
Train. So we are going to use the train set. Is it not? Use the train set. Hope there's no error here. Okay. Right. So if I have done that now, if I call classifier, let me run. Can you see something has come out now? Can you see it? Can you see that? So if I say summary of classifier, so this is like your logistic regression. Can you see that? Just the way you have your normal regression, you have logistic regression. So what does it tell you now? What does it tell you? Yes, what does it tell you? Yeah. What does this tell you? How do you interpret this now? How do you interpret it now? Yes, how do we interpret it? How do we interpret it? Yes. How do we interpret it? Statistical significance association between purchase age and salary. Okay, yes, you can look at them one by one, but another thing you notice that this one was using Z, the other one will be using T. Is it not? But again, it's the same thing you're looking for. Age, is it significant or not significant? Age, is it significant or not significant? Significant or not significant?
It's significant.
Significant, exactly. Salary, significant or not significant?
Significant.
Significant, exactly. Significant. All right. So now we have classified the model, isn't it? So now let us do a prediction now. So we want to now predict it, is it not? Now, how do we predict? How do we predict it now? Right? So what we can do, you know how we ran the initial one? You know how we ran the for your. So let's run it in such a way that let's look at the data set. Can you see the data set? Can you see the purchase? Is it not? So it means that let us predict now and see, based on this model, did it predict that this guy will purchase or not purchase? Can you see that? So this one means actually he did not purchase, 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 purchased, isn't it? Now let's check the predicted model. Will it predict whether this guy purchased or not purchased? Okay, so let's do that. And again, you know, most of these things, because it's prediction, that you have to now put it in probability form. So what is the chance that he will purchase, and what is the chance that he will not purchase? Can you see that? So we can predict the chance that he will purchase and the chance that he will not want to purchase. So what we can do, we can use this is called predict. Okay, so let's say predict. So what are we predicting? So what's the object? Classifier, right? Classifier. So predict classifier. Okay. Now, if I'm not clear, if I cannot remember everything, what do I do now? I will just put predict. I'll put question mark predict. So I'll come here now and check. Let me see. Okay, just the argument there is generic. Okay. All right, so let's do that. So classifier, okay. Now, most times, if I put predict, let me do it again. Predict. So bring it out in full. All right. Now, most time for your, when you're trying to predict, right, it will ask you what type do you want to do. Okay, what type of prediction do you want to do? So what you want is a response. Response. So what you are doing is called a response model. Okay. Now, what's the data? The new data now. Now, if you want to bring new data, right? So if I have new data, now in this case, my new data, right? I want to still use my train sets. I want to bring out my train sets because later I'm going to bring out my test set to test it as my new data. So I want to put back that same data. Let me see to what extent it can predict it correctly. But remember now that in this my train set, I don't need the dependent variable. Because remember, if I look at my train set, can you see my train set has my explanatory variables and my what? My target variable. But I don't want this target variable. I only want my what? I only want this. So how do I do it now? So I want to remove this last one. How do I remove it? I want only my features now. I don't want this my target variable inside it.
Is -1.
Now, if I look at it now, this is
-3.
1, 2, 3. So it means this one will be what?
-3.
-3, exactly. It will now be what? -3. So I will now put what? -3 there. Can you see that? Then let's run it and check. Aha. So can you see that? Can you see what has done? All these are what? The probabilities. Can you see that? These are all the probabilities. Remember that first one we ran? This one means what? 0. 0 means what? 0 means what?
Not purchased.
Not purchased. So the probability of him purchasing is what? The probability of him purchasing is about what?
Thank you. I'll pay you during the night.
Okay, and by the way, you see, it doesn't even use all of them. So this is 2 now. So this is 2. Can you see 2? This is 2. This is 4. Can you see that? Remember, we took it randomly, isn't it? We use this data random sample. So that's why I took it randomly, is it not? Just like that. So 2, 4. So just like that. So this means what? Probability of him purchasing is what? 2%. Probability of this person purchasing is what? 15%. Probability of this guy purchasing is what? About almost 0%. Right? Probability of 6 purchasing is about 1%. 8, 64%. Did he predict it correctly? Is he predicting it correctly?
Yes.
To some extent, is it not? Now, but you see, if you don't understand it this way, so that means let us put it on the table side by side. I think it will make sense better like that. So I can put it side by side so that we can see it now. So what I'm having here, how can I put it on the data side by side like this? So I can read it side by side. So what do we do now? So if I want to put it on the table, now how do I put it on the table?
That's like to add new columns.
Yes, I want to add new column, exactly. How do I add new column now? How do I add new column now? How do I add new column now? Yes. Now you know this whole thing we have already run it, isn't it? So what if I want to do it now? What's the data set now? This is your train what set, isn't it? So I want to add a new column called, let's call it probability. Probability, is it not? So that's the probability, is it not? Now I want to now what attach this to it. Can we see that? I want to now what attach it there. So let me see. Did you run? Okay, let me say view train sets. Let's run on view. Did it work? Aha, good, worked. So can we see it now? Can we see it now?
Yeah.
Can we see it now? Now, some will be correct, so some will not be correct. So. Can you see it, for example, look at this one now. This one says he purchased, but this one means there's 34% chance he purchased. This guy purchased, but he predicted there's 25% chance he purchased. This guy purchased, but he predicted that there's 22% chance he purchased. Can you see that? Can you see that? So some will be correct. Some will be, so this one was he did not purchase. I predicted 12% of him purchasing. These are not purchased, predicted 0 chance of him purchasing. Can you see that? So with all this now, it's just about what pattern, what recognition. There are some you will also see. For example, this guy did not purchase, but he predicted 57% chance of him purchasing. Okay. So on average, you will now check whether your model on average, how well it was has what predicted it. But if you want to do it the other way around, right? So that I will say 1 for purchase, 0 for not purchased, isn't it? So the only way I can do it now, how can I do it? 1 for purchase, 0 for not purchase. How do we do it now? 1 for purchase. So it means that if I check my data set here, it means that I want another one called predicted. Let me call it predicted. Is it not? Predicted. So where is 1? 1 means he predicted he purchased. Where is 0? He predicted he will not purchase. Right? So how can we do that now? So that means that anywhere we see this probability value greater than 50%, we assign 1. Where we see the p-value is less than 50%, we assign what 0. Because above 50% means what there's a chance to purchase, a likelihood to purchase. All right. So that's why you see where your probability now becomes very hard in how you interpret it. So in this case, now what do I want to do? I want to get my trade sets. So I want to call it now. What will I call it now? Predicted. Let's say predicted purchase. Okay, predicted purchase. Now, in this case, now what do I want to do? There's a function called if else. I think we did this function that if else. Did we do this? Did we not do this function? If else.
We did it.
If elif, is it not? If
We
else,
did
we
it.
did it now, right? Is it not?
Yes.
So you don't see where we. So you see all those basics we have to do. You see how we don't apply them. Because it's not just enough to just learn it, but you need to see how where it's applied. Okay, if else, so if what now? If what now? If what
Above
now?
51.
Yes. If that's your
Train sets $sign.
probability,
Purchase.
if this is your train set probability, is not is greater than 0.5. That is the logical test, is it not? If it's true, what happens?
Print 1.
1.
Print 1. Otherwise,
0.
0, is it not? 0. So let's check. I hope we're taking it in the right place. So we want to assign it. All right, let's see if this will work. So let's say view what now? View trade sets. Did it work? Yeah. It worked. So you see, actual purchased what? He didn't purchase, not predicted at what? He didn't purchase. Is it not? Predicted he didn't purchase, predicted he didn't purchase. Can you see that now? Now, these are where the differences are. He actually purchased, but he predicted he did not purchase because he predicted that there's a 34% chance he's going to purchase. But if I now decide to now reduce my probability value to about 30%, then you will get it up to this point, is it not? But most times, the high chance of it happening is once greater than 50% and above. Okay, so that's how he's doing his own prediction. Can you see the prediction he's doing? So that is prediction. So once we have tested it on the what? The trace set. Now, what is happening here is that because it has already seen this one, so there's a high chance that it's going to perform well. But on my test data, has it seen my test data yet? Has it seen my test data?
No.
It has not seen my test data now, isn't it? So now I want to test it. To now see, okay, take this new data set. Let us see how you are going to perform. Okay, so take the test data and let us see how you are going to perform. Okay, so take the test data and let us see how you are going to perform. So the same way, so I will now run it. So let me use test data. So prediction with test data. So let's go here. This was probability, isn't it? Okay, let me take this guy. Trade data. Where is the other one? Test data. Can you see that anything I do for trade, I'll do for test. So here I'll just change here to what? Test sets. Now here I'm going to change it to what now? Tests. Let us run and check. So let me view test sets and check if it works. Did it work? Yes. All right. So it means that this guy actually did not purchase, is it not? He predicted that there's 0 chance he will purchase. This guy actually did not purchase, predicted 0 chance. This guy purchased, but he predicted 30% chance of him purchasing. Can you see that? So which means if I use this other one to assign whether it's 0 or 1, so let me go back to my test sets. Predicted purchase. Let's use my test set again. Test sets. All right, let's run that and check. Good. So you see what is happening now, isn't it? So this is what 0 0 0 0 0 0. This is 1 0. This it did predict this one correctly, isn't it? Predicted all these ones correctly. Predicted one correctly. Predicted. Correct. Correct. Now you see in all these things now, because I cannot start going one by one to start checking, but I'm just checking randomly. Some will be correct, some will not be correct. So to now further test how well you have predicted it. So what do we now do? To now further test how well we have predicted. Now what do we now do? What do we now do? Yes, to now check how well we have predicted. What do we now do? Yes?
Is it the confusion matrix then?
Exactly. Confusion matrix. Remember how confusing that is. Confusion matrix. Is it not? So this is the actual. This is the word predicted. Is it not? So it's either I predicted it correctly, 1, or it did not predict it correctly, 0. Can you see that? So this is maybe like true or positive. Why this would be what? Negative. But remember, this is the truth. True. Because it's actual. Actual is true. Why this predicted? Is it not? Is that predicted 0 or predicted 1? Positive, this is negative, and this is what? Positive. Can you see that? So it means this is our matrix here. So this is our matrix here. So this is like our matrix here. So this is 0 0, is it not? 1 0. So what this one means is that You predicted that I would not purchase. Sorry, he actually did not purchase. This actually is not. He predicted that he actually did not purchase. So this is what? A true negative. True negative means I actually did not purchase. The model predicted that he did not purchase. True negative. He actually purchased. The model predicted he actually purchased. That is also what? True positive. Can you see that? True positive.
Yes.
Good. You actually purchased, but the model said you did not purchase. Can you see that? You actually purchased, but the model said you did not purchase. So it's going to be what? A false. What is false? It is a false negative. Okay. You did not purchase. You did not purchase. The model said you purchased. It's also false. Is it not? So it's going to be a false positive. Now, this false positive is what we refer to as what? Type 1. Is it not? That's what we call type 1. Why this one is called what? Your type 2 error. Type 2 error. And what is more important to us? Which one is the most accurate one? How do we know the accurate one now? How do we know the accurate one now? Which is the most accurate of all these ones for us? What's more important for us? Of all these, what is the most important for us?
True positives.
True positive and what?
True negative.
And true negative. So this is what is most important for us. Isn't it? So that is why if I want to get the accuracy will be what? My true negative plus what? True what?
Positive.
Divided by what? Everything. That is true positive plus true negative. Isn't it? Plus what again? False positive plus what? Plus false negative. So it's like adding up everything. That will give you my percentage. Because that's actually what you're checking, that you predicted it accurately. Okay? So that is your confusion matrix. Because remember, in these things, you are looking for accuracy, you are looking for precision. Accuracy, precision. But of all of them, what we're interested in is the accuracy of the model. So how do we do that? So to build your confusion matrix, what you can simply do, remember we have predicted value and we have the actual value, okay, on our test data. So let's check. So what we can do, confusion matrix. So if I want to build the confusion matrix, now what do I do now? It will be, so let me call it confusion matrix. Okay, let me put it in form of a table so that we can see it now. Table. So our test data, so we have our test set, you know? We have our test set, but in our test set, we need to remove the what? We need to remove that, you know, for our test set now, let's look at the data. Look at our test set. You know, this is the prediction. This is the predicted, actual value predicted. Then our model also predicted this value. So it's only this value I will pick in this case. So that means for this one, I will need what? 3. That's the last column, is it not? But I will need an entire row. So all rows, but give me the last column. Then what I did again is my, which one do I need here now? My predicted, this one now that I predicted. Isn't it? That's the one I predicted. So I can take my predicted value there. So let me check. Now, what I can do here, if I run that without work, let me try and see confusion matrix. Let's see. All right, good. So if I want to run confusion matrix, now let's run it. So what does it show you here? What does it show you here? What does it show you? What is my sample size? What is my sample size for my test data? What is my sample size for the test data? What's my sample size for the test data?
80.
80.
80.
80.
80 now. Now you see 1 0 1 0 1. I hope you understand what is written there.
Yes, sir.
1 0 0 1. I hope you understand what is doing there. It's just what I've explained here. Can you see that? This is my true. This is my actual. This is my predicted. So it means that from what it has predicted, it predicted 46 did not purchase. It predicted 19 did not purchase. Is it not? So 46 plus 19 will give me what? 46 plus 19, what will it give me?
65.
65.
65.
65 out of 80, what would that give me?
15.
Eh? 65 divided by 80, what will it give me?
Okay, I thought you said minus.
No, you can't subtract that. This is
5%.
the total. Remember, the total is now true positive, true negative, false positive, false negative. You have to divide by everything. So what do you have? 65 divided by 80, what will it give you?
0.81.
Eh? 0.81. So what does that mean? What's our accuracy level?
81%.
81%. So that was telling you that our model is what can predict what this 81% of the time. There's no model. So what you just keep doing, that you increase the features, right? Or you increase the sample data, but the more you break it, that's how you improve it. So that's what they now refer to as hyperparameter tuning. So now improve it. So this is how you normally do your what? Machine learning models using your R. So you can do that for your KNN, the same technique, only that you may change one or two things. For where you have GLM, you can call it KNN. You can have a gradient boost. All those other machines, just check how it's going with R, but it's the same technique. I hope this is okay.
Yes, sir.
All right, ladies and gentlemen.
Sir.
Yes.
One quick question. Like,
yes.
I know that in Python you could use other types of data, although like JPEGs and all those other things for predictive analysis. But can you do all those kind of things in R, or R is just numbers?
That's in terms of features, right? In terms of like pictures, videos, audio.
Yeah, data types, yes.
Yes, those are deep learning. You can do that in R. It's just to find out the right library to do that.
Okay.
Yes. All right, guys. I think I have to run. I have another session somewhere.
Thank you, sir.
All right, sir.
All right, please
Thank you so much, sir.
Try to practice this. So
thank you so much, sir.
Miracle.
Yes.
Thank you, sir.
Signs and wonders.
Thank you so much, sir.
All right, now take care. All right. Or you can go back again and check the one we did in Python and then check. Will I be with R, or let me go back to my Python?
Okay.
All right, guys. Take care.
Thank you. Thank you, sir.
All right, bye.